This is Geometry, Unit 6. We are going to be classifying quadrilaterals. We will be using the midpoint formula, we'll be using the distance formula, and we'll be using the slope formula. More often than not, we'll be using distance and slope. A parallelogram is a quadrilateral that has two pairs of what type of sides? Now this is arguable, but by definition, a parallelogram is going to have two sets of parallel sides. We know that a parallelogram is also going to have two sets of congruent sides. The opposite sides are congruent in every parallelogram. But by definition, that's what a parallelogram has. A rectangle is definitely going to have four right angles. It's also going to have opposite sides parallel. It's also going to have opposite sides congruent. But its uniqueness is the four right angles. A rhombus is going to have four congruent sides. The opposite sides are still parallel, but all the sides are the same, not just the opposite ones. And a square is going to have the same properties as a rhombus, the congruent sides, and it's also going to have the same properties as a rectangle, the four right angles. So every square is a rectangle, but not every rectangle is a square. Every square has four right angles, but not every rectangle has four congruent sides. Then a trapezoid has exactly one pair of parallel sides. All right, to show parallel, we have to show same slope or equal slope. That's going to be the parallel. Right angles opposite reciprocal slopes. That's going to give you right angles. Opposite reciprocal slopes show you that you have perpendicular sides. Congruent equal distance. We're going to use a distance formula. We got to do two distances and show that we get the same result. That would be the same thing here. Equal distance. Opposite reciprocal, same slope. So we'll be using the slope formula and we'll be using the distance formula to prove these different shapes. This first example is a bit tricky, mainly because the scale, if you look in here closely, the scale is different. It goes by 2s on the sides, but it goes by 1s vertically. So that means that the picture is not drawn accurately, the way it actually looks. It's not drawn proportionally, because your scale is not the same. You got to watch that. We know that J would be here, and K is 2 to the left and 8 up, L and M. So that's going to make our shape. And when we have our polygon, we don't know what type of polygon this is yet. We could say it has 4 sides, so I guess it is a quadrilateral, but what type of quadrilateral is it? Is it a parallelogram that has special properties? Or is it just a trapezoid? Or is it just an everyday quadrilateral with none of these properties? So one of the easy things to calculate first is slope. So let's determine our slope of our sides. We have JK. Just kidding. So we can count, but remember your scale's a little bit different. We're going up by 1, so 1, 2, 3, 4, 5, 6. But horizontally we go by 2s. So up 6 over 2. Up 6 over 2. That has a slope of 3. Or you could call it 3 over 1 if you want. That's JK. LM, to determine if this is going to be a parallelogram, JK and LM need to have the same slope. So 1, 2, 3, 4, 5, 6 over 2. So that's the same. If those are the same, then we know that JK is parallel to LM. Notice I do not use the line when we're using equal signs, but when we're just talking about the segment being congruent or the segment being parallel or even perpendicular, there we do use the line above the name. Let's take a look at the other two sides. KL. KL goes 1, 2, 3, 4 down, but 2, 4, 6, 8, 10, 12. Negative 4, 12. You have to watch the scale. The scale goes by 2s as we count to the right. So this actually reduces to a negative fraction. 4 goes into 4 once, 4 goes into 12 3 times. It doesn't really matter where we put the negative, on top or bottom. It's just one of them. Now what I notice is that KL is perpendicular to both of those. So KL is perpendicular to JK. We also know that KL is perpendicular to LM. So we have two right angles. You might be saying, hey, it doesn't look perpendicular. That's because the scale is different. You can't just use your eyes. You got to use your numbers to prove what you're doing. So we know that we have parallel sides. We could do the other set of sides if we want. We could do KL. KL is, we've done that, sorry. We did KL. We need to do JM. JM is down 4 over 12. That is also perpendicular to those sides. So again, I have right angles in those corners. So I have JM perpendicular to JK. And because they're the same, I also have KL parallel to JM. So right now I know I have a parallelogram for sure, because I have two sets of parallel sides, and I have right angles. So I know I have a rectangle. What I don't know is about the side lengths. So I could look at my side length JK. All right, my J and the K. So I have -4 minus a -2, and we'll square those x's. And I have a 2 minus an 8, and we'll square those y's. That's -4 plus 2 that we're going to square, because when you have a negative minus a negative, that means a plus. And here we have -6 squared. That gives me -4 plus 2 is -2. Squared is 4 plus 36. So this is the square root of 40. Can I simplify the square root of 40? Yes. But I'm just comparing. So I'm not going to force you to simplify the square root of 40 at this point. We're trying to figure out. I'm under the impression that my opposite sides are going to be congruent, so I'm not going to worry about that. I know it's a parallelogram. I'm going to compare it to KL, because that looks to be the same. KL has -2 minus 10, and it has 8 minus 4. That gives me -12 squared, and that gives me 4 squared. Whoa, this is much different. That's 160. So those are not congruent sides. So this is just a rectangle. So what we have, a parallelogram with 4 right angles. JKLM is a rectangle. We proved it. We did what's called a coordinate proof. We looked at the slopes, we looked at the distances, we ruled out this cannot be a rhombus, this cannot be a square, this cannot be a trapezoid, this is definitely a parallelogram with right angles. On the flip side, we're going to look at this quadrilateral WXYZ. We have -1, 4, that would be Y. We have -2, 1, that would be X. We have 6, -3, that would be W. And we have 5, 1, that would be Z. So WXYZ. Now look at this scale. If you look down here, you don't have numbers that are telling you how to calculate it. That means that that would imply that they go by ones. Okay, that's where we got all our dots. We just counted 1 over and 4 up. So we're going to do the same thing. We can use our brains if we want. Okay, it looks like we have 2 parallel sides. So let's go find out if they're parallel. I'm going to look at slope. Slope is an easy calculation. If it's on a grid, you can use the counting method. So for YZ, 1, 2, 3 down, 1, 2, 3, 4, 5, 6 over. Down 3 over 6. That's -1/2. It really doesn't matter what number gets the negative, so I put it right there in the middle. So that's the slope. You can count it if you want. Down 1 over 2, down 1 over 2, down 1 over 2, led you right from the y to the z. I'm going to do the same thing with wx, or we'll call it xw if we want. Down 4 over 8. So negative 4, positive 8. Those are the same. The slopes are the same. So yz is parallel to xw. They're going to be parallel to each other. Now I can totally see that yx is 1, 2, 3 over 1, and zw is 1, 2, 3, 4 over 1. They're not parallel to each other. So I have one set of parallel sides. WXYZ is a trapezoid. So we'll slide down to our next one. Quadrilateral ABCD. We have our points all plotted out. 8 over 4 up. That would be our A, and our B, and our C, and our D. Okay, I like slope. So I'm going to calculate slope first. We know that we have AB, which is up 2 over 1, 2, 3, 4, 5, 6, 7, 8. Up 2 over 8, that's 1/4. I suspect that that's going to be parallel with CD. Up 2 over 1, 2, 3, 4, 5, 6, 7, 8. So I see that these are the same. I see that AB is parallel to CD. I have a pair of parallel sides, so maybe this is a trapezoid. The slope of AD, 1, 2, 3, 4, 5, 6, 7, 8, backwards 2. So rise was 8, then backwards 2. That was negative 4. Oh, look at that. They are opposite reciprocals. BC is up 8, backwards 2. So we see that these are the same. So we know that AD is parallel to BC. So now I know I have a trapezoid. I'm sorry, I said trapezoid. Now I know I have a parallelogram, not just a trapezoid. I have two sets of parallel sides. And I have opposite reciprocals. AB is perpendicular to BC. I know that because AB is 1 over 4 and BC was negative 4 over 1. They are opposite reciprocals. flip the fraction and change the sign of the fraction. I know that BC, which is negative 1/4, is perpendicular to DC, which is 1/4. So those are perpendicular to each other, which is perpendicular to AD. And if you want to say that AD is perpendicular to AB, we have 4 right angles because they are opposite reciprocals in every one of those situations. So we have a parallelogram with 4 right angles. We think we have a rectangle, but maybe we have sides the same length. If we have sides the same length, then I have AD, that's AB. Right, if we do our distance formula, that's -8 minus 0 and 4 minus 6. That's going to be 64 plus 4. That's going to be 68. I already know this is a parallelogram, so I already know opposite sides are the same. But I'm going to look at the consecutive sides. I'm going to look at BC. So I'm going to use the BC letters up here at the top. I'm going to take the x value minus the x value and the y value minus the y value. Notice it's a -2, so I have to minus a negative. That means I have -2 squared, and I have 6 plus 2. Square a -2, you get 4. Square 8, and you get 64. And look at that. Square root of 68. 4 congruent sides, 4 right angles. A, B, C, D is a square.